Hi, this is Miss Fazone, and this is ratios of the sides of a triangle. So this is the start of trig. Okay. All right, so let's do a quick review of the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. Remember that c is always here. It's your hypotenuse. A and b actually don't matter. I typically do a, b, but it doesn't matter because addition is commutative. So it doesn't matter which one's a, which one's b, but c always has to be your hypotenuse across from the right angle. Okay, so let's do a problem. Use the Pythagorean theorem, we're going to find the value of x. So remember, a squared plus b squared equals c squared. So label each letter. This is my a, this is my b, and this is my c. For c, you can either leave it c or leave it x, doesn't matter. 3 squared plus 4 squared equals c squared. 3 squared is 9, 4 squared is 16. 25 equals c squared. If 25 equals c squared, take the square root. C equals 5. So the value of x is 5. Now, technically, when you take the square root of a variable, it's plus or minus 5. But since we're talking about the sides of a triangle, you don't have to worry about that. Okay. All right, one more. How do we use the Pythagorean theorem? Okay, again, label. Now, which one's the c here? C is 13, again, across from your right angle. And then again, doesn't matter, a, b. So I'm going to do 5 squared. 5 squared plus x squared equals 13 squared. 25 plus x squared equals 169. Now remember, you're trying to solve for x, so you have to minus 25. X squared equals 144. Square root. X equals 12. Okay, done. Okay, so now we're going to actually kind of jump into the trig. This symbol in here, it's a 0 with like a line through it. It's a Greek letter. It's called theta. All right? Do not call it the 0. It's called theta. What kind of triangles are these, if you look at them? Well, if this is 4 and 5, what was that triangle we started with? This is 3. And the same thing here, this is 10, right? So if you do Pythagorean theorem, it's 3, 4, 5, 6, 8, 10. What kind of triangles are these? They're similar. When you have similar triangles, there's a relationship between the sides and the angles. Remember, with similar triangles, the angles are the same, and the sides are in a ratio. So there's a this ratio has specific names. Okay. Write this down. There's a ratio between the sides of a right triangle and the angles of the triangle. The ratio of the sides are always the same. We have names for these ratios, right? So for instance, the ratio of this side of 3 over 4 is the same as 6 over 8, because 6 over 8 is 3 over 4, right? So there's a relationship there. So here are the 3 main ratios. We're actually going to talk about 6 today. But here's the 3 main ones that we use the most. Sine is actually spelled S-I-N-E. It's shortened to sine. Do not call it sin. And that's the opposite side over the hypotenuse. Okay. Cosine is adjacent side over hypotenuse. And tan is tangent. Right? So those are the real names. And tan is opposite over adjacent. So when we say opposite over adjacent, notice it's sine of the angle, cosine of theta, tan of theta. So what side is opposite of theta? Opposite, across from. So this is your opposite. Where's the hypotenuse? That's your hypotenuse. And adjacent is next to. Okay. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over hypotenuse. Okay, and there's actually kind of a nice mnemonic device that's really popular, and it's called Sohcahtoa. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. When I found this, I thought it was cute. All right, instead of hypotenuse, it's hippopotamus. Okay. So what I want to start with is label the opposite adjacent to hypotenuse, because if you can't do that, you're going to be a disaster. So from the angle, where's opposite? Where's your hypotenuse? Opposite's across from the angle. Hypotenuse opposite your right angle. Whatever's left over is adjacent. It's the leg that's next to the angle. Right? Do the other two on your own. Pause the video, draw it. Hypotenuse, opposite, adjacent. Again, across, whatever's left over. Across, whatever's left over. Okay. So now we're going to write down the ratio for each of them. Okay. So I'm going to do 6 over here. 6. Sine of theta equals cosine of theta equals tan of theta equals. So the first thing we're going to do is label. So where is my hypotenuse? Put H. Where's my opposite? And where's my adjacent? Okay. Now sine is opposite over hypotenuse. So I'll write it down here. Sohcahtoa. Sine is O over H. So O is 3, H is 5. And we're done. That's it. That's all I'm asking for. Just a fraction. Cosine is adjacent over hypotenuse. The adjacent is 4. The hypotenuse is 5. 4 over 5. And then the tangent is opposite over adjacent. So 3 over 4. And that's it. Okay. Try number 7 on your own. Same thing, even though there's radicals, it's okay. Not going to kill you.